In this brief tutorial, we're going to talk about the use of raster and vector data together. We're going to use the example of zonal statistics. First, we're going to talk about a method to extract those values in the raster file to a polygon file so we can get some information at individual polygons that's stored in those original raster file. Here on screen, I have a raster file of the human population for Vietnam from the WorldPop website. So every 100 meter by 100 meter pixel has the total number of people estimated from a statistical model. The second file I have added here is the administrative boundaries for the districts of Vietnam from the GADM website. So I have a polygon vector file of administrative units, and I have my raster file of human population from WorldPop. Our goal in this exercise is to extract those values and aggregate those human population estimates up to the polygon level. And to do that, we're going to use the zonal statistics routine. In Q-GIS, the zonal statistics routine is under the raster analysis tools in the processing toolbox, and we have a zonal statistics tool that we can launch and get a dialog box to populate with our data files. And we can see the two pieces of information we'll need. Here we need our raster file. I'm using one called reprojected, and it's a single band, so I don't have to select which band of information. If I had a multi-band layer, I could select different bands. And I have my GADM admin level 2 that we've been using, the district level. And I can name this output column. So I'm going to name it pop underscore to remind me that this column contains population data. Next, under the statistics to calculate, I'm going to select what I'm interested in. And in this case, I'm just interested in the sum. I'm interested in the total estimated number of people per district from that raster file. So I'm going to select sum. This means that every statistic calculated will be named pop underscore and then that statistic. So we'll get pop underscore sum will be the new column added to that shapefile's attribute table. So we're going to create an attribute for the polygon based on the analysis of counting up all of the pixels in a given polygon and adding up all the people. I'm going to run this algorithm. And we've concluded the zonal statistic routine, so I can close this dialog box. And if I now open the admin table for my polygon file, the attribute that we've just created is going to be at the end. So I've scrolled to the right, and here you can see I have a pop underscore sum. So now I have a new attribute that I can work with to do further analyses with the polygon file or to build a Choropleth map of population. So using those population data that we've just aggregated from the raster file up to the district level polygons, we can make a Choropleth map or a graduated color map of population. So let's look at that example. First, I'm going to launch the layer properties by double-clicking on the file name. And what we want to do is adjust the symbology from being a single symbol, the default single color that we have here, to a graduation. And by graduated, we mean that each individual bin or color that we're going to add to the map will have an increasing value based on a change in the intensity of the color. The first thing we have to select is that new column. That's the attribute that stores the population data. So I'm going to select PopSum. And for method, we're going to have color. And for color ramp, I'm going to select Viridis. And then I'm going to invert that. And the reason I'm selecting this color ramp for this example is that if you go to the WorldPop website and you look at the data that's presented there, those data are presented with this color ramp. For this example, I'm just going to select quantile, 10 classes, and apply. And now I have a color ramp that shows me where the highest population of people is found, or the locations of highest populations are found. Those are the darker colors, and the low populations in the lighter yellow colors. So for this example, we started with a raster file of population and a polygon file of geographic boundaries, political boundaries, and we used the zonal statistics routine to summate or aggregate those population that's stored in the pixels of the raster up to the polygon level so we can make a Choropleth map. We then use the symbology tools of the polygon to make a graduated map. And by graduation, we mean that with each increase in color, we get a change in value that's increasing from low to high.